Ah, sorry, I DC.
Yes.
Sorry, I DC. The, the question one, the new improvement. Can we do we talk about the functionality or do we add new things?
Types of improvement. I believe you have done the quiz, right? The quizzes, those
I
types of improvement. Is it clear?
not so clear.
If you refer to the system planning, I think it's in chapter 2. You have learned the, how many? 5 types of improvement for the existing system. So based on that particular point, you write your answer by using the airline system as your scenario.
Oh, thank you.
All right. The time now is 12:15. I would say submit before 1 p.m. Because okay, good.
are small, what area we must finish.
Noel, are you there?
Yeah.
Can you rephrase your answer so that you include the case study, the scenario like the airline. If you just mention it in general, it seems that you are not answering accordingly lah. Can you recheck the airline? And also question 2 is on the, what was it already? Retail, is it? The change for. Okay, change accordingly. Same goes to Kelvin and Farah.
Rephrase means
Please add in the name of the company or the staff of the company. If you just mention like end user, it's too general.
oh,
Okay, you have 10 minutes left. Noel, let me check yours first. Okay, it's, you have 5 minutes left. Okay, I'll check yours first, Calvin. Kelvin, I've already downloaded yours.
Oh, check already.
Yes, you answered according to the scenario given. Farah, you have 3 minutes left, yeah? Farah, you need to turn in your answer now. All right. Okay, let me check. Okay. So I see it already, yeah? Let me download yours. Okay, I've downloaded yours, yeah, Farah. So I'll see you in 5 minutes time.
Okay.
Okay.
Okay, so let's start with our short lecture. I will make it quite, let me say, not that hectic for you. Okay, a very simple stuff that you all need to cover. I'll start the recording now, and you can open your chapter 7. Right, you can open your chapter 7. Since we are for our tutorial, we are ahead of 1 week. Okay, we are 1 week ahead. So the continuation for our chapter 7 will be done this coming Thursday lah. So we cover a little bit during these 30 minutes, and then finish off the rest of it during our 1 hour tutorial. Okay, the tutorial for this chapter we will discuss next week. Let me start. Now I think we are finishing off our system design phase. There's one more design that we need to cover, which is on the procedural design. Now, once we have completed the procedural design, then we can compile everything in our deliverable for the system design phase, which is the SDS, the system design specification. Okay. Design specification, right? This is in slide almost to the end of our chapter. We have in this document, deliverable, the output from the system design phase would be everything that we have covered lah. Okay, a set of documents used to record details of the design, and all this interface design, database design, including what we're going to cover this week, which is procedural design, will be compiled in this SDS. Okay. Now, what we are covering is not an object technique, but a structured technique, as what has been mentioned earlier on, SDLC, structured system development life cycle. We are using a structured approach. Therefore, we are using structured techniques to do basically all of our documentation and also the tools that we use. Now, try to recall in system analysis when we do the fact recording, means after we have conducted an interview perhaps, okay, and then based on the interview notes, then as a SA we can draw a DFD for that particular current system, right? And if you remember in DFD, we start off with the context diagram, which shows the system name, and then we explode the process 0, which is the system itself, and we have the diagram 0 DFD. Diagram 0 DFD shows all the main processes in the system, and if we check any of the processes in the diagram 0 and explode it further, say I take process 1, and for the example like this, then I will have 1.1, 1.2, 1.3, and so on. Now, if I can explode further, then it will be diagram 2. So I will have 1 point, say, to confirm the order, perhaps can be exploded. So I will have 1.1.1, 1.1.2, 1.1.3. So that is in diagram 2 DFD. Once we have reached to the sub-processes which we can no longer explode, then we can say that that particular process is already at the functional primitive. Okay, this is what I'm trying to get at, right? DFD functional primitive is a process at the lowest level of explosion. So if I check this process 1.1 and 1.2 as the lowest level of explosion, means I can no longer explode it to the next level of child diagram, then we say that process 1.1 confirm order, process 1.2 validate order has already add the functional primitive. Now the next question is, how do we describe the order validation process? How do we describe the order confirmation process? Because during the system design phase, SA need to make everything very clear, especially the procedural design, because next phase is the system development. During the system development, this is where SA will assign the programming task to his programmers. So the programmers will need this description of all the processes clearly. So we have a variety of structured techniques to describe the process. The primary use for us to use these techniques, first of all, the programmers need to do, when they do their coding, then their input validation, the computation logic, how it is being computed, also how to produce the output. Okay. Now, the main techniques that we use for these logic definitions, okay, say I am the SA, I want to describe the order confirmation process, order validation process. I can do a flowchart. I believe you have learned how to draw flowchart earlier on. And then similar to flowchart is a box diagram. It's not used in our syllabus, but there is a picture of it just to show you how it looks similar to the flowchart. The only difference is that it is using different notation. Okay, and then the one that is mentioned here, I think displayed in red color, are the important techniques that we need to know. We have the structured English, SE, and we also have decision tables and decision trees. Now, for our syllabus, we'll go slow with the last two, decision tables and decision trees. I'll cover this in our lecture on this coming Thursday. So I hope you all will not miss the lecture, our lecture. For today, just cover the theory part for structured English as well as the pseudocode. I'm sure you have looked at how a flowchart and a pseudocode looks like earlier on during your first semester programming and problem solving, if I'm not mistaken. Now, program flowchart, again, these are the tools that is, we call it as a graphical tools, where it can help us to describe the procedures in very detail, very widely used previously. So the diamond symbol represent a condition, and each of the processing step is represented using the rectangle. So in sequence, then you can see the flow of the sequence using the arrow. And then if there's a decision, then you will see two arrows coming out to show the true false part. Okay, and then this is an example for selection. In this case, it's the switch. And repetition, we can see there's a true while loop, and this is a repeat until. Now, box diagram looks like this, whereby there's no arrows at all. We just see boxes, okay? Boxes are nested inside other boxes. So if it's a sequence, then one box after another. If it's a selection, then there's something like, what do you call this, a triangle. the right hand side denotes the true part, and then the left hand side is the false part. And then for the repetition, it depends on whether it's a do while loop or repeat until. Then the checking of the condition, where it is done, it will be shown. Okay, if the condition is outside, then you can see that the block of statement that need to be repeated is enclosed inside the box. Okay, and then what if for the selection you have more than one actions, then that is the switch. So for the switch you have various cases, right? So this is how it is being represented in a box diagram. For syllabus we will not be using box diagram lah. Okay, show you just an example for a sequence process to process the purchases. Step 1, step 2, and then this is a repetition, and then followed by 2 more steps in sequence. Now we look at the structured English. Now, here it says that structured English, apart from the decision tables and decision trees, are very important for our syllabus. But I would like to give more emphasis on the step 5 and 6. Okay, structured English. Okay, it looks like a spoken English. Okay, when we use spoken English statements, it is easier for us to describe the program operation. However, it will be a bit wordy. Okay, when it is wordy, it tends to be ambiguous. Therefore, at the end of the day, it's not that appropriate for analysis. But on the other hand, the main advantages for structured English is that since the structured English resembles a programming language, programmers find that it's easier to understand, right? And for users themselves, the end users, it's using structured English, is using spoken English. Therefore, they also find it easy to follow, right? Remember, when SA need to come up with the designs, okay, before he can proceed to the system development phase, the end user must give their green light. Okay, they can move, means everything is in order, everything is correct in terms of the design specification of the new system. Okay, so in order for them to check, then normally SA will try to use structured English, okay, so that users can check for them that the explanation for the processes, for example, to how they do the order validation, how they confirm the order, is properly done. Okay, this is an example of a structured English for processing of the customer order. Okay, in sequence, the first step, obtain customer details. So this is in spoken English. It's very straightforward. Everyone can understand this. Subtract 1 from stock on hand, print customer invoice. Okay, very clear. And for repetition, say to describe how they calculate the daily total orders and updating of the customer record, there's certain keyword being used for structured English, like do while. Okay, and then this would be in typical spoken English. They are order in orders, so meaning while the orders file they are still have record, then they will keep on doing this tree. Read the next order, display, calculate, and then it will ends when there is no more orders. Okay, so this is how the structured English looks like, right? But then the pseudocode will have more keywords, okay, compared to structured English. Structured English, it is using more spoken English. Okay. Now, conditional block, this is another example on how to describe calculating of the discount percentage based on the quantity ordered. Okay, remember that this is a procedural design, something that need to be added into the system design specification. So if you assume you are the programmer, you will be taking a look at this procedural design, perhaps using the structured English in this case, and you can do your programming. If the SA unable to describe the process clearly, then there will be a problem during the system development. Okay, when you look at this structured English, you, as a programmer, you have some kind of idea how to do it, right? Okay, like assign daily or total to 0. This is the initialization of the variable. Okay, and then we can see that is the if statement and so on. Now, this is one exercise to show how we come up with a structured English. And the exercise is about describing the loan application processing. Okay, how to process a loan application. So these are the conditions. If the customer has an account, there's no outstanding, then approve the loan. If the customer has an account but there's outstanding from previous loan, then need to obtain management approval. Check whether approval is given. If yes, then loan will be approved. All other cases do not approve the loan but reject the loan application. So this is how it looks like. Okay, structured English. All right, then if I am the programmer, it will be easy for me to do the coding. And take note that we have a nested if else statement here, right? If close with an if and so on. A proper indentation plays a very good part here. Now, what's the disadvantages of structured English? It's not that easy to use because there's the indiscriminate use of the commands borrowed. If you notice here, if condition then, or this looks like a pseudocode, correct? Before that, it doesn't really use lots of keywords. Okay, so there might be confusion between a structured English and pseudocode. So one of the disadvantages is this one, okay, indiscriminate use of the commands borrowed. And another one is that why we seldom see structured English is that it is only suitable to describe small processes. Okay, only suitable for describing small processes. That's it. Okay. Now for pseudocode, the difference would be there are more vocabulary from the real program code. Okay, so that's why the name pseudocode. Pseudo means false, means a half code, half not code. Okay, pseudocode, we can see that pseudocode is similar to, and then because it borrows the vocabs from real programming language, and then at the same time, it is also supplemented by the natural language, which is English. Okay, one more thing that you need to know is that even though pseudocode, we borrow the vocab from a real programming language, it is not language dependent. So what does it mean? It means programmer, they do not have to worry about syntax, programming syntax like I must declare variables, no need. Okay, and because of this, there's no need for them to be concerned about these language dependent details, okay, the syntax. Then they have more time to focus on the correctness of the logics, okay, more time to focus on the design of the process. Okay. Another thing mentioned as the last bullet here is that each programmer has his own style. Yeah, that's why you can see a variety of pseudocode. Somehow it looks like a structured English, and depending on the background of the programmer, it might include some borrowed keywords from the language that they are using. Okay, and pseudocode, since it's not a real code, we cannot execute the pseudocode statement. Yeah. Okay, this is the example of pseudocode. The syntax, I split it into two. The syntax is on the left-hand side, and the example is on the right-hand side. If you notice, here we are using the operators, in this case the conditional operator in the condition. Okay, item price, is it less than 100 ringgit? If yes, then do this calculation, right? Compare this with structured English. Do we have any? We can see that it is also using the conditional operators. Okay, so there is some kind of overlapping here because of the disadvantage. The first disadvantage. Okay. Advantage is not easy to use and understand. The pseudocode is actually prepared design, yeah, and the programming, the development phase. Okay, and then pseudocode can be supplemented with some natural language description, and then
Miss,
oh, laggy already. One
Thank
moment,
you.
yeah. Okay, can you all hear me clearly now?
Yeah.
Yeah.
Okay, all right, let me continue. Since which part that you all cannot hear me clearly?
Just now the no,
This
not this
one?
one. Not this one.
This one.
No.
Okay.
Just now you're explaining the what
Advantages.
no. I don't know how to say. The condition. The condition.
Condition.
Uh,
Ini.
the condition block there. You're talking about something. We didn't hear.
Starting from here.
Right.
Okay. Thank you. Now let me rephrase again. For structured English, it's more like a spoken English, but it is wordy, therefore it's a little bit ambiguous, therefore not appropriate for analysis. But then why sometimes SAS still use structured English is that end users find that it's easier to follow. Like for example, this is using spoken English, so it's very easy to understand. Obtain customer details, subtract one from stock on hand, print customer invoice, and so on. If it's a sequence statement, so it's one English statement after another. If it's a repetition, then we can see a keyword here where the indented statement will be repeated. Okay. Notice that for each of the example, we have the explanation like this is to describe how the customer order is processed. This is how to describe how to calculate the daily total orders and how to update the customer records. Okay, and then for conditional block is in fact your if else and also switch lah. Okay, in this case it is describing the discounting process. Okay, how to decide on the discount percentage based on the quantity ordered. Now, the exercise that we see here is using structured English to describe how the loan application should be processed. Normally, we will get this from our end user, meaning during the interview. All right, perhaps you can also see this during the system observation and so on. So the in terms of procedural design for a structured English, it looks like this. So it's very clear, easy to understand, right? However, this disadvantages is that there's an indiscriminate use of commands borrowed. It's sometimes we will confuse ourselves with a pseudocode and also a structured English. That's why we have this as one of the main disadvantages. And then as you can see, all this, okay, they are describing a particular process that is not complex. So structured English is only suitable for describing small processes. Therefore, we have pseudocode. Pseudocode is another way, compared to spoken English, right? A pseudocode, it looks more like the real programming language, which has been supplemented by natural language, which is English. However, since it is not language dependent, there's no need to concern about, say, variable declaration. Okay, and then with this, programmer can or the designer of the procedural design can focus on the correctness of the logics. Okay, and if you do your research online, pseudocode, there are a few varieties because each programmer has his own style. And do
So,
take note.
so the code, is there no standard way to answer in our test?
Different company, they have their own standard, and then that's why you can see variety lah.
What about task C when we want to answer pseudocode?
For that one, then you need to follow the notes. Okay, follow the notes, then should be no problem. But when you start working, I believe your team will be given the template for it lah.
Okay.
Okay, good. So even though pseudocode is, it looks more like a real programming code, but then it's not executable, yeah? Okay, I think I can finish off already. So if you look at this example, there's no need for us to concern with the, what we call that? The language dependent details, like we must declare the variables. So you can see here, do we show, Okay, declare variables, no need lah. Okay, so
do,
that one
do
is
we
no
need
need.
RM? Do we need to write RM? Can we just write 100 if there's a unit given?
Both are acceptable,
Both
but
are
then to show, yeah, because a pseudocode looks more like a programming language. Normally we use lots of these operators like arithmetic operators, conditional operators, and some people they prefer to remove the RM lah.
Okay.
Okay, so the advantages, easy to understand by programmer because they can start from pseudocode and easily translate them to the programming language. Okay, and then things like initializing of the counter can be explicitly coded like this. Okay, and explicitly assign 0 to the cell stack, something like this. All right, for the initialization. And in terms of the language independent, already mentioned earlier on that there's no need to focus on variable declaration. And disadvantages, this is what normally people will say like double coding. Okay, happen when programmers they start writing in actual programming language. So what happened, it's like it is written twice, once in a pseudocode and another in real code. So it depends on the company where you are working, right? Whether it's how the SA come up with the procedural design of the system. Okay, like perhaps he's used, instead of a pseudocode, he's using structured English, or if he's using pseudocode, then during the system development, the programmer only need to translate it into coding. Okay, so normally the procedural design are done by the SA lah. So to avoid this double coding. But I would say by preparing the pseudocode, okay, if SA prepare the pseudocode, then it will be easier for the new programmers, the junior programmers to do their programs. Okay, it will really help the new programmers, those with no experience yet. Okay, another thing is here, a programmer will not be able to differentiate between program coding and also program design. Lead to a programmer focusing too much on coding rather than design. This will be eliminated if you remember what I say just now. The procedural design, which is the pseudocode, should be done by the SA during the system design phase. And only during system development, then the coding will be done by the programmers. Okay. Next would be, if you look here, the pseudocode, it's not suitable to describe like a control structure, especially when you have nested if, nested else if, all those. Therefore, instead of using pseudocode, SA will use either the, where was it already, either decision tables or decision trees. I will cover these two this coming Thursday. Let's see, I think we are done. So I'll cover this on Thursday. Okay, that's all for today. Yeah, there's a delay of 5 minutes because of the lagging. But then so far you all can hear already, okay?
Oh, yeah.
Okay, so I'll see you on Thursday. Bye bye.
Okay. Thank you, Miss.
Welcome.